Good afternoon. Where are others? Absent. Many are absent today. Some festival is there? Test when? Afternoon. Afternoon also test is there. Okay. You had test now? Over. Completed. How was it? Good. No response from this side. How was it? Here, how was it? Good. Always girls will say good. That too only this area. That side, back side again gone. This side to silence. That side dead silence. So, anyways, what were the questions? Huh? Pass by value, pass by reference. Huh? Custom exception. Okay. Huh? Voucher. Virtual polymorphism. What is virtual polymorphism? What is virtual polymorphism? Virtual polymorphism is one method can do many things. It's a false polymorphism. And how do you achieve that? Method? Overloading or overriding? Think once again. Overloading itself. Are you sure? 100%. Okay, sit down. Fine. So in yesterday's class we were actually discussing about linked list, right? So how is linked list different from array list? Array list needs contiguous memory allocation, correct or not? But linked list needs contiguous memory allocation or dispersed memory? Dispersed memory. So even if there is no contiguous memory, you can make use of linked list. Is it clear to everyone? So before I continue the discussion on linked list, I would just like to ask you a simple question. I will give you two scenarios. Let's assume that you became ultra rich. After you get a job, you did another job, you did another job, you worked on your skills, you learnt a lot of things and you became ultra rich in the next 10 years. Now, what is that you wanted to do is, you want to construct one airport for your flight. Is that clear? That rich you are. So, if you want to construct an airport for yourself, you need to purchase a land or not? Yes. So, let's assume that you want to purchase some 100 acres of land. So, can you purchase 10 acres in BTM, 10 acres in Jayanagar, 10 acres in Koramangala, 10 acres in Marthaldi, 10 acres in some other place like Vijayanagar? Can you do like that? Then what should you do? All that 100 acres should be in one place or not? Yes. So, if you want to build an airport, then all that area whatever you purchase should be in one place. Correct? Why? Because that's how the airport is built. Is it clear to everyone? So, if you need to do that, don't you think you need to go and find some space which is empty and you need to acquire all of that space or not? Yes, you need to reserve that space and keep it for yourself. If you do not reserve, someone else will come and take that place. If someone takes places in between, can you go and use that place later on? No. Is it clear to everyone? Great. One more scenario. You thought you will not buy any flight or make any airport or anything. Let's assume that Bangalore, so many young people are coming, they are new freshers coming, getting a job, and after that they want to enjoy the city life in Bangalore, they want to go to clubbing and all of that. So you decided you will open pubs. So in this situation, if you want to create a pub, do you need land or not? Yes. So you will create one in BTM, one in Silkboard, one in Marthaldi, one in Koramangala, one in Vijayanagar. Is that possible or not? Yes. In this situation, should you reserve all the lands in one place and then do it, or one by one you can acquire it? One by one you can acquire. So in the first situation, can you acquire one by one? No. You need to acquire everything in one shot. But when it comes to your second scenario, when you are creating the pubs, don't you think you can acquire one after the other? Yes. Because you don't need any reserved space. You can take whenever you have the money and you want to purchase. Is that clear to you? Any doubts in this? Great. Now let's start linked list. So yesterday what we have seen is, we have seen how the linked list is created. We have also seen that when it comes to data structures, there are two majorly different types of linked list. One is single linked list and the other one is doubly linked list. Now I also mentioned internally when it comes to collections, we actually make use of linked list. What is the underlying data structure of the collection linked list? Is it single linked list or doubly linked list? Doubly linked list. Great. Apart from that, there are other properties as well. Let's see one by one. So the underlying data structure is doubly linked list for your linked list. The next thing that we have over here is, it is most appropriate for adding and deleting the elements. Now why is it most appropriate for adding and deleting would be a question. We will discuss on that particular. Now apart from this, whatever we have studied in the list, all of that is also applicable. What are the properties we studied in the list? Insertion order is maintained. Next. Null insertion is allowed. Next. Duplicates are allowed. Next. Indexing is maintained. All those four properties are also applicable along with this properties. Is that clear to you? Great. So these are the properties of linked list. Any doubts in this? Now how can we create linked list? So there are different constructors to create linked list. Let's see one by one what are the constructors. Please keep your books closed. So for the first one that we have is, we will simply say new linked list and we will pass 0 parameters. Now whenever I create a linked list like this, will it create, what will be the underlying data structure? Doubly linked list. Will it create a linked list? Yes. But will there be any specific memory reserved for this or not? If you ask me, what do you think? Will there be reserved or no reserved memory? There will be no reserved memory like arrays, because arrays needs contiguous memory, that is why it will reserve. But linked list, does it need contiguous or does it need dispersed? So it will not reserve. That's the example I told. If you want continuous spaces for airport, what you need to do? You need to reserve. But if you need dispersed space for your pubs, one over here, one in another place, do you need to reserve or no need to reserve? Same way linked list works. It doesn't want to reserve because it is using dispersed memory. So there will be one empty linked list which will have null and null. There is no starting, there is no ending. That is what I mean. Next, one more way of doing is by saying new linked list, and you can pass the collection as a parameter over here. So same thing, whatever we have seen in array list, same thing you have over here. So in case if you have an array list, if you want to convert into a linked list, pass the array list over here. Automatically a new linked list will be created and it will have all the elements whatever was there inside the collection. If you have a hash set and if you want to convert that into a linked list, all you need to do is pass that hash set as a parameter over here. It will create a new linked list where all the elements of hash set will be present inside your linked list. Is that clear to you? So if I need to show an example, let's assume that C2 is a collection that I have. When I say C2 is a collection that I have, this particular collection has these elements, that is 5, 3 and 7, and one more element that I have over here is 9. This can be an array list, this can be a linked list, it can be a vector, stack, hash set, linked hash set, tree set, priority queue, priority blocking queue and link blocking queue. It can be any one of that. I can pass any of this collection to this. When I do that particular thing, a new linked list is created and all the elements present inside this collection will be present inside that linked list, and this is what it will do. So you will have 5 inside that, you will have 3 inside that, you will have 7 inside that, and you shall have 9 inside this. And this is how your new linked list will be created. Is it clear to everyone? So these are the 2 different ways of creating a linked list. One with 0 parameters and the other one with 1 parameter, which is accepting 1 collection. Is it clear to everyone? Any doubts in this? So we have seen what are the properties of a linked list, and we have also seen how to create a linked list. Means what are the constructors of linked list. Now apart from all of these things, we need to understand when it comes to linked list, there are some specialized methods as well. Now what are the specialized methods that is present? If you know specialized methods, right? What are specialized methods? It is not inherited from the parent. Means it is not inherited from the collection, nor it is inherited from the list. These methods are specifically available only in case of linked list. What are those if you ask me? The first one that I have over here is add first. This is the first one I have. Add first, what will it do? It will accept one object and it will add at the starting of the linked list. If I need to diagrammatically show it to you, this is how it will look like. Let's assume that this is the list that I have, or this is the linked list that I have. When I say add first, where should the element get added? Over here at the ending, or somewhere in between, or at the starting? At starting, the element has to be added. So if it has to be added, is the linked list making use of contiguous memory or dispersed memory? Dispersed memory means first that node will be created. What do we call this as? Node. So first one node will be created anywhere in the memory. After creating that node will be added just before this. How does it do it? Very simple. I will show it with an example. So I will say lst.add first, and I will need to add 200. So first one node will be created like this. What is there in this? 200. At starting, when it is created, you will have null and null. But say me, if this is the first node, what will be the second node? 10. Don't you think? So after 200, which element will come? 10 will come. So don't you think the address of this one should be present over here or not? Yes. So over here inside this link, you should have the address of the 10. Same way, over here, if this is the first node, will you have any address or will you have null over here? Null is what you will have over here. And if this is the first node, LST will be pointing to 10 or LST will be pointing to 200? It will be pointing to 200. So this is what you need to do. So basically what you are doing is, step by step, you need to make sure that LST is pointing here, you have null over here, this is referring to this. And at the same time, over here again you will have null, or this will start referring to the 200. Before 10, what is there? 200. So the previous link of 10 will also point here, and the next link of 200 will point to 10. And that is what exactly happens. This will point there, and from here you will have the reference over here. Is it clear to you? So this is how you are adding one element. When you say add first and 200, somewhere in your RAM, this node is created. Now LST is pointing to this, so 200, from here it goes to 10, from there it is as it is, no changes after that. Now, I just want you to use your common sense and say, what is the time complexity of this? Are you shifting anything? No. What are you doing then? You are just creating one node and making some connections, that's all, correct or not? So what is the time complexity? Big of n or big of 1? Big of 1. So basically the time complexity for add first, what is it if you ask me? It is big O of 1. Is that clear to everyone? So let me write it in the bottom. Next, after this, let's check another method. In case if I want to add the element at the last, then we have a method called as add last. Now let's see how exactly does it work with an example. So I will say lst.add last and I will pass 200. So if you need to add the element at the last, after 40 that should come. So what happens is, Since linked list makes use of dispersed memory, randomly at the end or somewhere in the RAM it will create one node, and inside that node you will have this 200. Now say me, if this is the last node or if this is the last element, will there be any link from here, or there will be no link from here? No link from here. So what you will have over here? Null. The previous of 200, what you will have? 40. So should it store the address of this one or not? Yes. Similarly, after 40, is there an element or no element? No element. There will be element, correct or not? If there is element, over here should it be null or should it start pointing to 200? Start pointing to 200. So this is what we need to do. This should point over here and this should point over here. Is that clear to you? After that, over here what you should have is null. So say me, what is the time complexity of this? Is it same as the previous one or not? Yes. So this is also big O of 1. So if you want to add an element at starting or if you want to add an element at ending in a linked list, the time complexity is what? Big O of 1. Is it clear to you? Great. Let's assume that I want to remove an element from the starting. So I can say remove first. When I say remove first, am I passing any parameter? No. Which element will be removed is the first element will be removed. If I need to remove the first element, say me, if I remove this element, which will be the first element? 10. So LST should start pointing to this. If this 10 is the first element, over here, will it point to the previous node or will it say null? Null. You should have null here. Should this be there or should this also be null? If you have the address over here, what does it mean? This is pointing here. Should you have the address of 10 or you should break that link? You need to break that link, means put a null over here, put a null over here. So what happens is, from here going over here is broken. From here coming to here is also broken. Is that clear to you? After both of that is broken, this has nothing to do with the linked list. LST should point to this or LST should point to 10? 10. So that is what should happen. So that is all we will be doing. When you say LST dot remove first, what happens is, basically that will point over here and this will become null. So whatever you did in add first, you will just do the reverse of that particular thing. Is that clear to you? Great. Similarly, if I want to remove the last element, there is a method for that as well. What is it? Remove last. How do I call the method? I will say LST dot remove last. What should I do in this? Very simple. Over here, if I need to remove this, which will be the last element? 40. So what will come over here? Should it point to any element or it should not point? Means what will come? Null. So you will break the link from here to here. Same way, should you break the link from here to here or not? Yes. So you put one null. Automatically this will be disconnected. Is that clear to you? That is all you need to do. 2 places null if you put, your job will be done. Is that clear to you? So now if you see, the last element is remove. Can you say me, what is the time complexity for remove first? Big O of 1. What is the time complexity for remove last? Big O of 1. So basically you mean to say the time complexity of all these 4 methods is big O of 1. Is that clear to you? Great. Now what I want to do is, I want to get the first element. How do I get the first element if you ask me? I will simply say get first. What will it do? It will simply, whenever you take a linked list, internally there will be pointers. If you actually go and learn linked list, you will understand there will be 2 pointers called as head and tail. Head will be always pointing to the first element. Is that clear? And tail will be always pointing to the last element. So whenever you say, so basically there will be 2 pointers like this. Let me show diagrammatically to you. So there will be one pointer over here, which will be called as head. And there shall be one more pointer, and this will be called as tail. Now what happens is, when you say get first, what will it do is, wherever head is pointing, whatever is the element, it will return that element. That's all it will do. So for example, if you say LST dot get first, wherever at is pointing, what is it? 10. Is that the first element? Yes. It will just return that particular element, so you will get the first element. Similarly, if you want to get the last element, you will simply say LST dot get last. If you say LST dot get last, what will it do? It will go directly wherever the tail is pointing, and whatever element is present in that tail, it will just return that particular element. So it is saying LST dot get last will return the last element. So what is the time complexity of all these methods? Big of. Now say me, is this memory contiguous memory or not? Is it contiguous memory or not contiguous memory? Not contiguous memory. Now one user will come and say LST dot get 3. Can I call the get method for linked list or not? Yes or not? Yes, I can call. Why, if you ask me? Because indexing is maintained for a list or not? That was the property of a list. So what I will do is, I will simply say like this, LST dot get of 2. When I say LST of get of 2, the question is, will it directly jump to that which is the element in index 2? 30. Will it directly jump to 30 and give me that particular element, or will it go step by step and give that element? Step by step. If you had observed the diagram carefully yesterday, will you randomly know the address of every element, or should you go from starting to ending? Starting to ending. So basically what you will do is, you will start from the head. You will say 0th index. You will count that 0th index. You will go to the next one. Index 1. Am I looking for index 1? No. Then you will go to the next one. Am I index 2? Am I looking for the index 2? Yes. Then it will give this element. Are you getting the point? It cannot directly go over there because it is not contiguous memory. If it is contiguous memory, if you say get of 2, it will apply some formula and directly jump over there. That's how arrays work. But in case of linked list, that's not how it works. This is the internal working of array list and linked list. Is that clear to you? Now, say me, if there are 10,000 elements, and if I say LST dot get 9,000, can it directly fetch from 9,000, or should it go from 0th index till 9,000 step by step? 0 to 9,000 it has to go step by step. Means, should it not go 9,000 steps or not? It should go 9,000 steps. If I say LST dot 9,999, should it go step by step from 0th index till the last one or not? So basically, is it going n steps again and again and again and increasing the count every time or not? Yes. So in that situation, if I make use of a get method, can you say me what could be the time complexity? Big of 1 or big of n? So in case of get, the time complexity is going to be big O of n. So say me, for add and remove, what is the time complexity? Big of 1. And when it comes to fetching the element, what is the time complexity? Big of n. So say me, linked list, is it good for fetching the element, or is it good for adding and removing the element? Adding and removing the element. And that is why I showed you in the property that linked list is good for adding and removing the element. So if you have any situation where there is a lot of adding and removal of elements, what should you use? Array list or linked list? Linked list. But you don't have much of adding and removing, but you have lot of retrieval operation. What should you use? Array list. Is that clear to you? So you can clearly see, you didn't learn the whole data structure, but you already know what should be used at what situation. This is the beauty of collection. Even without learning data structures for days together, months together, immediately you know. And why do you know all these things? Is because you know what are the properties, you know what are the advantages, you know what are the disadvantages. Is it clear to everyone? Any doubts in this? This is all about array list and linked list. Any doubts till here? If you have any doubts, you can let me know. So now the question is, how do we create an object of linked list? Exactly the same way you created object of array list. But you will not say new array list. What will you say? New linked list. How will you add the elements? Add. Same method. How will you remove the element? Remove. But if you want to remove first element and last element, there are extra 2 methods for that, which you don't have in array list. If you want to add the element at starting and ending, you can either make use of indexing, or without indexing also you can do by saying add first, add last. Is that clear to you? Similarly, if you want to get the first and the last element as well, you can do get first, get last. And all these methods works based on the head and tail pointers, because a doubly linked list will always have head and tail pointers. Similarly, if you learn data structures, you will understand single linked list will have only head, no tail. Is that clear to you? This is all about linked list as a collection as well as data structures. So there is nothing much to learn, or because the code everything remains same. Is that clear? Good. Fine then. If you have understood both of these particular things, let's go and learn a new collection. What was the next collection that we had? Vector. Okay. So let's see how to create a vector. If you need to create a vector, all you need to do is say new vector. Now the question is, when I say new vector, what is the underlying data structure? Is it array, or is it linked list, or is it something else? It is array, same as your array list. Is that clear to you? So it will create one array, internally it will create one array. What is the size? 10, same as array itself, array list itself. So that is what will happen. One more way of creating is, you can say new vector and you can give the initial capacity. Have we seen this in array list or not? Same thing. If you already know that you need to add 2000 elements, is it directly good to give the initial capacity directly, or keep increasing again and again? Directly you give that 2000, so it doesn't have to create 10, then 16, then 21 or something, and doesn't have to keep increasing like this. Is that clear to you? So you can directly give the initial capacity over here. One more way of creating is what? We have already seen. Collection you can pass, whatever you have seen in the linked list and the array list, same thing. You can say new vector and you can pass the collection. Do you know what it does? What does it do? It will convert from one collection to another collection. So you can pass any kind of collection over here. So all these 3 things are exactly same as your array list. But there is one more extra. What is extra if you ask me? This is the extra one. What do I mean is, it will take 2 parameters. One is initial capacity and the other one is incremental capacity. What do I mean by this initial capacity and incremental capacity is, we have already seen, if we give if we directly say new vector, if the underlying array is full, is it going to actually create a new one or not? Yes. Does it apply an internal formula or not? Yes. If you don't want to follow that formula, you can do that as well. How? You need to say new vector and you need to give the values. How do I do it is, you need to say new vector, and now what are the parameters you are passing is 2 integer values. So what I will do is, first one is initial capacity, I will say 5. Second one is incremental capacity, I will say 20. So what exactly happens is, first it will create one internal array, or underlying array will be how much? 5. Means, what is the initial capacity you have given over here? 5. So internal size will be 5. If 5 elements are already filled and you want to add the 6th element, what will happen? Will it apply the internal formula? No. What will it do is, it will say whatever is the current capacity plus 20. Why 20? Because 20 is your incremental capacity. So it always increases by 20. So first time it is 5. What will be the capacity next time if you ask me? It will be 5 plus 20. 5 plus 20 is how much? 25. it will create an array of size 25. If 25 elements are filled, if you are adding the 26th element, it has to increase the size. It will not follow the internal formula. It will apply your formula. What is that? Is whatever is the current capacity plus incremental capacity. So how much is the incremental capacity? 20. So what will be the new size? Sorry? 45. That would be the size. Next time what will be the size? 65. Every time it will keep adding 20. So basically new capacity is equal to current capacity plus incremental capacity. So this is the formula that it shall follow. When does it follow this formula? Only if you call this particular constructor, only then it will follow this formula. But if you call any of these constructors, it will not follow this formula. What formula will it follow? The internal formula, whatever is there, that's the formula it follows. Is that clear to you? Do you remember the internal formula for array list? What is it? Current capacity is equal to, new capacity is equal to current capacity into 3 by 2 plus 1. Great. That is of array list. For linked list, what is the formula? There is no formula. Current capacity plus 1, add one element, one new is created, that's all. Is it reserving and keeping anything? No, so there is no formula and all for that particular. Is that clear to you? Great. So these are the 4 different ways of creating a vector. Any doubts in this? No. So apart from this, let's see what are the properties of vector. Now what are the properties of vector if you ask me? What is the formula, what is the default capacity if you ask? The default capacity of vector is equal to 10. So the default capacity will be equal to 10. Just give me a minute. Okay. I hope you understand when I say default capacity. Next, what is the formula for the new capacity? Underlying formula if you ask me, new capacity is equal to current capacity multiplied with 2, not into 3 by 2 plus 1. It is not that complicated. If starting capacity is 10, it will double it, double it, double it. Very simple or not compared to array list? Yes. Rest all the properties remain same. Is that clear to you? Rest all the properties means what are the properties of array list? Underlying data structure is array. Underlying data structure is array. Next, what was the property? Indexing. Indexing is maintained. That list one, everything is there. Apart from that, there were some other things, right? Sorry? Heterogeneous elements can be stored. That is also there. Next. Duplicates are allowed. Yes, duplicates are allowed. Null is also allowed. Next. Index done, no. Insertion order maintained. Next. Needs contiguous memory allocation. Yes, this also needs contiguous memory allocation. It is good for retrieval. Is it good for retrieval or not? This is also good for retrieval. Why is it good for retrieval? Because array list follows array as internal data structure. Even this also follows array only as internal data structure. So array is also good for retrieval. This is also good for retrieval. Array is bad for adding and deleting. This is also bad for adding and deleting. Is that clear to you? Right. But still there are some differences. So what are the differences is what you say. Your core Java is completed or not apart from collections? Everyone? No, whoever is saying which concept? Multi-threading. What concept in multi-threading? Not yet started. From tomorrow it will start. Okay. Fine. So let's see the difference between the array list and a vector. Whoever has not studied multi-threading will not understand. But don't worry. Methods are not synchronized. Those who have learnt multi-threading, you know what does it mean? What does it mean? God knows. What does it mean? Who has studied multi-threading? Raise your hands. Oh, sorry, wrong question. Who have not studied, who multi-threading is not yet started? Raise your hands. Okay. Hands down. Now, what does synchronized mean? I will ask one by one if you don't answer. Have you seen this word or not? What does that word mean? Okay, fine. Basically the difference is whenever you used to mug up in colleges, how you used to mug up? Array list, methods are synchronized. Vector, methods are, not synchronized, synchronized. Array list, not thread safe. Vector, thread safe. Array list, race condition exists. Vector, race condition does not exist. That's all is the difference. 3 line mug up. Easy. Fine, we are done with this. What? You didn't learn multi-threading. I am asking who have learnt. They are also not answering. What should I do for that? Anyways, I will give you one example. Because I cannot teach you multi-threading in 5 minutes. So I will give an example. When you learn multi-threading, you will understand it very clear. Is that clear to you? Example is very simple. I will get you one cake. Assume. Not real. So that cake, whatever I am getting you, is of 1 lakh rupees. Wow, amazing cake. The best cake in the world, prepared by the best chef. I don't know, chef or whoever prepares, I don't know their name. Let's assume the best chef has prepared one. So all 100 students are here. I am not getting 100 kilos cake. For 1 kilo, it is 1 lakh rupees. One day I will get that cake and I will keep over here. I will say, whoever wants the cake, please come and have it. How will you come and have it? Will you say, 1 lakh cake I will not touch? Will you do like that, or you will first and come and have it? I will not look at you. I will turn that. Will you come and have or not? Don't worry, I will not put any. You understood? What? Yeah, I told honey. Poison and all. Oh my God. Shantam Papa. So, basically, I have kept 1 lakh cake over here. Now, what exactly you will do is, 1 lakh rupees cake, maybe the best cake in the world, you will run and come and you will take piece, over. Everyone will they get or not? No. Do you think everyone would have had properly? No. Half of the cake will be down. Because everyone is in a hurry to have that particular. Correct or not? So, are you all racing for that cake or not? That is only race condition. Is that clear to you? Now, is there only one person coming and having the cake, or multiple people are coming and having the cake? Multiple people. So, whatever cake you see over there, that cake is nothing but a resource. It is a eating resource. Is that clear to you? And each one of you are coming and having that cake. Means you are doing something. It is a behavior. You are eating. Eating is a behavior or not? Yes. How do we represent behaviors in classes? Methods. So basically, there is a method using that particular cake. Means using that resource. Is that clear to you? So, but when it comes to computer science, we will not have cake. We will have variables. Is that clear to you? You can have a string object, or you might have an array list object, or you might have a linked list object, or you might have a vector object. Like this, these are all different resources. But in reality, we have cake, but over there, you have different variables or different objects. Is that clear to you? Now, in this cake, what exactly happened is, everyone rushed to this, having this particular thing. Everyone wants to eat. So, same behavior or different behavior? Same behavior, but same person or different person? Different person. So, each one of you are considered as a thread. What is thread? You learn in multi-threading. Before you learn thread, you need to learn what is process. So, lightweight process means small part of the process is what we call as thread, not that this thread. I hope you understood. Is that clear to you? So, now Each one of you are threads. So are the threads racing for this cake or not? Yes. That is what you call as race condition. Is it clear to you? Now, when there is a race condition, resource is maintained properly or is it getting corrupted? It is getting corrupted because it is getting wasted here and there. Every threads are not able to access it properly. This is what is happening. Is it clear to you? Now what I will do is, you know one guy will take your attendance every day? Yes. I will say him, let they come however they want. I will keep the cake before they come. And you let only one person inside. Is that clear to you? And that one person should cut a small piece and walk outside. Once he walks outside, only then he will let the second person inside. Then the second person will have the cake, he will walk outside. Only after the second person goes out of the door, the third person enters. Now, is there race condition or no race condition? No race condition. Is your resource getting corrupted or not getting corrupted? Not getting corrupted. Why, if you ask me? I have kept a person over there to monitor this. And what is the job of that person? The job of that person is to let only one thread at a time. And that one thread, what will the thread do, if you ask me? That thread will come and eat. Means it is executing eating. Eating is a behavior, correct or not? So it is executing one method at a time. So all of them are eating together now, or only one is eating at a time? In technical terms, if I have to say, if there are multiple threads now trying to execute the same method, what is the method? Eating. If it is trying to execute the same method, earlier it was able to do it, now it is not able to do it. Why? Because I have kept a person. So how many of them will be able to eat at a time? One person or multiple people? Only one person at a time. So in other words, if you have created a method, all threads will not be able to access that method at the same time. Only one thread will be able to access at a time. And how is this achieved technically, if you ask me? Technically, I can't make that person stand in front of that method. So I will use a keyword called as synchronized. If I keep that keyword called as synchronized in front of that method, automatically that synchronized keyword will make sure only one thread executes at a time. Is it clear to everyone? Because of this particular thing, is the resource safe or not? Safe. That is what we call as, it is thread safe. Is that clear to you? Even though there are multiple threads, it is still safe. Why is it safe? Because there is a person, and that person only I am calling it as synchronized. So if the method is synchronized, is the resource safe or not? Yes, it is safe. Is there race condition or no race condition? No race condition. But if there is no person over there, means if there is no synchronized, is the resource thread safe or not thread safe? Not thread safe. Is there race condition or no race condition? Race condition is there if there is no person, correct or not? This is the difference. Is it clear to everyone? Yes. Now you see the differences. So when I say array list, the methods present inside the array list is not synchronized. If it is not synchronized, means no person. If it is synchronized, means there is a person. If it is synchronized, is it thread safe or not? It is thread safe. If it is not synchronized, is it thread safe or not thread safe? Not thread safe. Race condition exists or not? Yes. If it is not synchronized, race condition exists. If it is synchronized, race condition does not exist. Is that clear to you? This is the only difference between array list and vector. Along with that, that formula is the other difference. And one constructor is another difference. That's all. But major difference is this. Is it clear to you? So in a multi-threaded environment, will you use array list or vector? You will make use of vector. But if it is not a multi-threaded environment, you can make use of anything, but the best option to use is array list, because vectors are very old in Java. Array list, they will keep doing improvements in this particular thing. Is it clear to everyone? Any doubts in this? No. So if you want to see the proof for this particular thing, I will just take you to the editor and just let me just show it to you. So what I will do is, I will create one object of array list. I will say new array list. So this is the array list class. Is that clear to you? I will take you to the top. Can you see class array list? Public class array list. All the other things you ignore. Now, inside this, if you see the methods, let's see one by one. This is constructor, ignore the constructors. Trim to size, there is one method. Is it synchronized or not synchronized? Not synchronized. Ensure capacity, grow, like that there are so many internal methods. Then there is size, which you have seen. Synchronized or not synchronized? Not synchronized. Is empty, synchronized or not synchronized? Not synchronized. You scroll down any methods, each of these methods will be not synchronized. Now let's go back. Let me comment this line. Let me create an object of vector. I will show you the code of vector as well. If I open the vector class, this is the vector class. Where is the vector class? Starting. Class vector. You can clearly see over here. Now let's go and see the methods present in vector. So what I will do is, I will just scroll down to the methods present. These are all constructors. Trim to size, same method, but it is synchronized. If I scroll down, ensure capacity, same method, synchronized. Grow, and after that set size, capacity we have seen synchronized, then size synchronized, then is empty synchronized. This is the case. Is that clear to you? That's the difference between an array list and a vector. Is it understood or not? Yes. That's all is the difference between vector and array list. Any doubts in this? All those who have not attended multi-threading classes, understood? Yes. Who have attended, understood? Great. So, you remember string buffer and string builder? What is the difference between string buffer and string builder? One is thread safe, whereas other one is not thread safe. What do I mean is, whatever differences I showed now, same differences. There is no other differences. Is that clear to you? So which one is thread safe, which is not thread safe? String? String. Thread safe you say. Buffer or builder? Some are saying buffer, some are saying builder. Nice. So we can go and see the source code of this as well. So let's go and see the source code of string buffer and string builder as well. So have you already seen in multi-threading classes? String buffer. This is string buffer. I will create string builder as well. Let's open both the implementations. This is string buffer. Methods are synchronized or not? Yes, in string buffer the methods are synchronized. So which one is thread safe, string buffer or builder? Huh? String buffer. Some are still saying builder. I don't know what you understood. So much cake, 1 lakh cake I gave you. Now if you see the string builder, is it synchronized or not? It is not synchronized. So, is it clear to everyone? Any doubts in this? Great. That's all is the difference between string buffer and builder. So, if anyone asks you the difference between string buffer and builder, same difference. For string, vector and array list, same difference. Is that clear to you? But when you give an example, in detail you give the example. Is that clear to you? Simply if you read it out, nobody will understand. I also read it out. Did you understand or not? Or you are like, what is this? That is how some reacted. Correct or not? But when I explained in 5 minutes, did you all understand or not? Yes. So please take 5 minutes and explain to the interviewer as well. Is it clear to you? Any doubts in this? Are you sure? I have practiced explaining to people for years together. How many hours have you practiced? Every day I will practice 7 hours. How to explain to someone. How many hours do you practice? So don't think you will be able to explain like me. If you think I will be able to explain exactly like sir, it's not going to happen. So please make sure you go to your PG and at least practice it, is what I mean. I am not saying I am awesome, you are not. I am just saying that if you practice, only then you will be able to explain. If you don't practice, you will not be able to explain. Is that clear to you? Will you practice? Yes. Not only thread safe, not thread safe, everything. Whatever you have studied till today, make sure you practice how to answer. Any doubts?
We can give the cake example to the interviewer.
If the interviewer is chill enough, you give the cake example. But along with the cake example, did I connect the dots equally with technical as well or not? When I told cake, behavior, thread, I also showed what is behavior, what is thread, what is resource. Equally I was connecting the dots, correct? If you can connect the dots like that, you connect. If you say only cake example and if you don't connect with the methods and threads, then please don't give cake example. I gave airport and pub. I connected the dots. If you can connect the dots, you give that example. If you cannot connect the dots, then you will think, what airport and pub is he speaking about? Got it? Yes. So, it's all about how you will connect the dots. Any doubts? No. Yes? No. Please make sure you remember this well, because again, I will show some more examples where some are thread safe, some are not thread safe. Only once you need to remember, same story, copy paste, copy paste, copy paste. Same concept, copy paste. Is that clear to you? So do it well. And one more thing I am saying. Till now, if you had observed me, I have started using polymorphism, I have started using interfaces, I have started using multi-threading. You will see by the end of collections, each and every concept of Java that you have studied, whether Rohit sir has taught you or Mallikarjun sir has taught you, you will have used that one. So please make sure, if you have already bunked some of the classes, go and watch those videos. If you don't watch those videos, come to class and if you open your mouth and sit, then you will see different avatar of me, that's all. Is that clear to you? And I also don't like to be like that. But if you irritate me by not studying and simply coming and sitting in class, you didn't take admission to simply come and sit in class. You took admission to make sure you build a proper career. So please make sure you work towards it. So let's continue. What? 12:15 I started the class. Some of them came at 12:30. It is just half an hour. Sir, half an hour only, right? Some problem in my watch? Oh, it is correct. Now, half an hour only I have taught this. I mean, not half an hour, more than half an hour, but for some people it is just half an hour. Because I saw 12:30 also, some were slowly coming, sitting that corner, this corner. So, anyways, let's continue. Okay. I will conclude the class. But one small story I will say and conclude. Okay? Only 2 minutes it will take. Just 2 minutes. What happened? Sorry? Huh? No, I will say the story. You are saying sir, no, I will say the story. What happened is, exactly some 4 or 5 months back, I was teaching one concept. So, I was actually teaching about hash map and hash table. So, I explained the concept and I told how I explained now whatever differences. Same way I explained one differences and I told. One girl was sitting in that corner. She was like, I was like, I explained so well, why is she doing like this? Then I asked what happened. She told, sir, half an hour back I had one interview. I answered all the questions, sir. One question they asked at last. Difference between hash map and hash table. I could not answer because I didn't know. Just immediately after half an hour, you are teaching that, sir. Just 1 or 2 classes before that, I told them, I will complete it so that it will be easy. They are like, sir, same like you. If I had actually taught, she would have got placed that day. I didn't teach because all of them told, sir. So you told, sir, I am leaving. Bye. Have a great day. We'll catch up tomorrow.
When I have learned polymorphism, I have learned that two types of polymorphism is there: runtime and compile time. Runtime overloading and compile time. Overloading and then overriding that runtime. But here we are learning new concept virtual. What does virtual mean?
That is only compiled in polymer.
Overloading one.
These are different names.
Okay.
I have also, your polymorphism classes is okay. No. In that I will say, this is also one.
Because when I have chat GPT search Google search, there is no word like virtual means in the
False polymorphism or this particular.
no, runtime and compile time are there.
They are standard terms.
Okay.
These are, now for example, there is nothing but a core Java and advanced Java. There is
SE
and E. That is a thing. But throughout the industry, people will say core Java.
Okay.
These are some terminologies which is not documented, but it is there as well. Word of that.
So if you want to input object type of input using the scanner, so how to read that object type? For example, if you want to scan the text field.
I will show that in the next class. So learn setters, getters, constructors and come tomorrow. ಖಂಡಿತಮ್ಮ ಹಲೋ ಇಲ್ಲ ಎಂತ ಆಚೆ ಹಾಂ ಕೊಟ್ಟಿರೋ ಚಾ ಹಾಂ 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 ಆಚೆಗೆ ಅದು ಎಂತ ಅದನ್ನ ಒಳಪಿಚ್ಚಿಡೋವ ಕಟ್ಟಾಯಿತು ಬಂತು ಮಾಡ್ಕೊಳ್ಳೋಣ कम फोटो है ना ए सी काम बताना है ಇಕ್ಕಕ್ಕೆ ಎಂತ ಮಾಡೋದು ನೀವು ಅದು ಚೆನ್ನಾಗಿ ಕ್ರ್ಯಾಕ್ ಬಾತಾಣಿಚಂಗೆ ಅದು ಈಸಿಲಿ ಪೊಟ್ಟುಕೋಬಯ್ಯ ಹಾಂ ಫೋಟೋ ಇಕ್ಕಲೆ ಆಯ್ತಮ್ಮ ಅಮ್ಮ ಹೋಯ್ತು अच्छा 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 ಇಲ್ಲ ಕೊಟ್ಟಿಂಚ ವೀಡಿಯೋ ಮಾಡಿತ್ತು ಫೋಟೋ ಎಲ್ಲ ಫೋಟೋ ವೀಡಿಯೋ ಎಲ್ಲ
OBS का रिकॉर्ड है बस.
OBS.